here you have to have another element. See, this is that's this friction, and between these two the difference is seen by two elements. This is C element like that, R element like this. And I would say that we are done with this stuff. I mean, if you want to make it look a little nicer, you could, yeah, this is fine, but you know, perhaps just for aesthetics, I'll just erase this one in here and do a little nicer job on the line. You could make it look pretty by doing this. There you go. A little less crowded, but that's it. So this is the bone graft model of this. Is there any questions about this, or something that I can answer about this? For example. There is room for simplification on this, and you could, if you like, simplify a little bit some bonds on the side, like this whole thing will become zero, you know, because it's zero. So it would make this collapse to here. This one will collapse to this one here, to the other one, to this one. So that we could give it a try, but really it's not necessary. Maybe I should do it just for learning purposes, but let's just assign the causal marks to make sure things are right in here. First to the sources, or let's just do it with a different color so that we can do this well. Okay, so there we go. So this is, then we assign it, there's to this one, to this flow, like this. Okay, in here you have the integral form for the I. Now pay attention to this. The moment that this sets the flow for this junction, the others have to be like this. See? And in here, the moment that this sets the integral form, makes all these others like this. And this has these two like that. It needs a junction E. And then that one makes it and determines to be like this. Where else can we go? We have in here the I element. See here, this bond is not drawn very well. It can't be like that. It needs to be from here. So just a small correction in there. So that is this one. Yeah. Okay. So where we were assigning the causal marks over here, and then you have this, then makes this one like this. Let me see. Right here. And so it makes it this too. That determines this. and that determines this. See, right now we have this SF. This has to be like this, all of them. So then this is like this. Okay. And what else? The C is in integral form like this. We need something to complete here, and that I want to make sure that, oh, this is also like this because of the 1. And once you have that, it completes very nicely. This, I repeat that this, on the numbers, you do not need to make an emphasis on that, because the computer program will do it for you. I'm only doing this because I had asked you to do the graph and the model. Now, if you want to simplify this, which I also really do not encourage you to do, because you might lose a little bit of the interpretation of the graph, relating the graph to the real system. So the thing to do here is, if you want to experience the reductions a little bit in here, I would do this. I would keep, maybe I'll pick this coloring here and put 1 with SC over here, and then this I would be like this. The 0 that goes to this 1, you would see that one would through power simplify to this, and this of course will continue with the I over here, yeah, and then you have another 1 and the 0 here, that over here could get simplified, and then you'll have just this. Okay, now we have, this is, yeah, so we simplify that. We don't really need to, we don't have an option to simplify this, so this is going to be a 1 with the C on the R element like this, yeah, and then right after this you could say, oh, you know, if I simplify and set this to 0, all these guys really don't exist. And if that's true, look what happens here. Through power to the R element, it means that R element would be like this whole branch at the top, and this one would be also through power, because in here we have the I element, let's not forget, and since this is being made 0, this will, this I with that R would go here. This would be the simplified bond graph model, but I am concerned that if you do that, you know, you lose this reference point in here. I think maybe you gain a little bit here, but I don't think it's too much of a gain. You know, the bond graph is not all that different, maybe about 3 bonds different. The computer has no problem handling this stuff, but I think it's I wanted to show you as an example of what you can do with a to get a mechanical system structured nicely and directly to the in a certain order so you can't go wrong. Okay, so we're done with this one.